Do I need this?
Yes, you'll need to flick through.
Hi, welcome back, everybody. How was break? How is the energy? How are your energy levels today? Oh, that was just one person. So how are your energy levels today? Yay, cool. That's what I wanted to hear. Before we get started, I just want to remind you that you can send us feedback. You can head over at Slido also for the panel later in the afternoon. We're gathering all your questions there, so please, if you have anything that you would like to ask the core team or the other speakers, please head that way and ask your questions. We also want to give a huge shout out to our sponsors again. This event would not be possible without them, so thank you again so much for joining us again this year. Before we get started with the program, I want to introduce Theo. He's the CEO and co-founder of Cloud&C, and he will give a short presentation about himself and the company. So welcome, Theo, please.
Hello, everyone. Theo Saville, co-founder and CEO of Cloud&C, and I'm here to very briefly tell you about manufacturing with Angular. This is what's known as a computer numerically controlled milling machine. Most people have never seen or heard of these things before, and yet they're responsible for the production of almost all manufactured goods. In fact, they make about $120 billion worth of components every single year, serving every single manufacturing vertical. You can think of it as being the literal opposite of a 3D printer. You start off with a huge block of material, and then you use powerful spinning cutting tools to carve it into a useful shape. Now, this is a pretty difficult thing to picture conceptually, so here are some video clips to help give you an idea of what it looks like. And you can use this process to make anything from the body of a MacBook or turbine blades, pieces of satellite car, ship, structure, other CNC machines. There's almost nothing that you can make without involving one of these somewhere along the line. Now, unfortunately, the world of manufacturing has been somewhat left behind when it comes to computing technologies. So this is the kind of user interface that you would be expected to grapple with if you want to actually input cutting instructions to make something. This is absolutely impenetrable. And this is the kind of software that you would be expected to use to actually convert a 3D file of something that you want to make into cutting instructions that you then load into the machine through one of those panels. It is just phenomenally complex. When it comes to manufacturing metal parts to the incredibly high precision required by the engineering industry, there's just no equivalent to the 3D printing world, where you can just upload a 3D file, press a couple of buttons, and within minutes and no expertise required, just get the instructions for your machine. Instead, the process is largely manual. You, to make a component like this, might have to sit in front of a computer, operating computer-aided manufacturing software for anything from 1 to, in extreme cases, more than 600 hours. Now, at Cloud&C, we're working to bring to precision manufacturing the same levels of ease of use that you currently find in the 3D printing industry. Now, existing computer-aided manufacturing software is almost exclusively desktop-based and monolithic, largely due to the extreme hardware requirements of generating and simulating cutting tool paths. Our advanced software, on the other hand, utilizes cloud-based servers to do that computation, and this gives us the freedom to use a modern web-based user interface. Now, with the modern web, we can use real-time technologies to deliver what, for manufacturing, are groundbreaking features, such as real-time collaboration and cross-platform support. And at CloudNC, we use Angular as the backbone to orchestrate a number of modern web APIs, including gRPC, WebGL, WebSockets, and web workers. Now, an example of a challenge that we've faced in building our software includes handling client-side language parsing within a web worker in order to avoid blocking the main UI thread, all the while handling a complex data flow of actions to and from a WebGL service. Significant parts of our application have information flowing from multiple sources, and we found that Angular with NGRX and RxJS has been ideal for handling that complex logic in a way that actually becomes pretty straightforward and elegant in the code. The use of these technologies has enabled features like real-time collaboration to almost come for free thanks to the built-in multiple response nature of observables. We have a stand outside in the hall. If you'd like to come and learn more about how we're using Angular for manufacturing, then please come and talk to our devs. We're actively recruiting for a senior and multiple lead-level developers, and we would love to meet you. Okay, that's it, guys. Thank you very much, and enjoy the rest of the conference.
Thank you so much. That's actually really cool. I like that. Right, so next up on stage, we will have Grant. He's an engineer at Google, and he's working on the G Suite APIs. He loves Node very much. He also likes open sourcing a lot. And then in his spare time, you will find him playing the saxophone, right?
Yes.
Awesome. Please welcome Grant.
Thank you so much.
Hi.
Thank you. Hello, everyone. Welcome to Automate G Suite with AppScript and Angular. My name's Grant Timmerman, and I'm a developer platform engineer at Google. So I work at Google in San Francisco, where I work on G Suite developer products. Today, I'm really excited to teach you how you can leverage Google AppScript and Angular to quickly build powerful applications. These are some of the G Suite products that I work on. But first, let's take a selfie. Right? This means 自拍. This is Chinese for selfie. Great. I don't know if I can get everyone, but let's try. If my camera app loads. 3, 2, 1. No, okay, I definitely need to upgrade my iPhone to an Android phone. Really? Are you serious? Okay. That would be lovely. Could we get a selfie?
It's already set up.
Oh, great. Okay, I don't know if I can get everyone, but let's try. Let's get the crowd. Woo! Great, thank you so much.
You're so welcome.
And my camera app is still not working. Okay, so before we begin, let me give some introductions. First, G Suite is the set of collaboration and productivity tools within Google Cloud. So you can see Google Cloud includes everything from Google Cloud Platform, G Suite, Maps Platform, Chrome Enterprise, and Android Enterprise. Today, I'm going to be focusing on G Suite. So G Suite includes everything from Gmail, Drive, Google Calendar, as well as our editors, Docs, Sheets, Slides, and Forms, and our administrative tools, the Admin SDK, and Google Classroom for EDU. AppScript provides a layer of abstraction for integrating Google APIs from Gmail to Google Calendar. Angular provides a complete client-side solution for web applications. Together, I believe with AppScript and Angular, you can build powerful web applications to automate tasks in minutes. But these cool things don't really matter if you can't meet users where they are. Today, I want to show you how you can build add-ons with Angular and AppScript within Google Sheets. From a high level, we'll be using the following. First, Google Cloud will host our application in our server-side code. AppScript will be our backend service that will interact with Google Sheets as well as other APIs. Angular will be used for our front-end web components. This tool called Clasp is the AppScript CLI, and it'll allow us to use TypeScript. And we'll also use some other tools like Stackdriver logging within Google, the YouTube API, Gmail's API, and even GitHub. With AppScript, you have Legos. You can build it incredible. It's really up to whatever your mind is the limit. So let me show you a demo in action. Cool. Can you all see the sheets? Great. So here I have a Google Sheet. It has actually the list of speakers for this year's event. You can see we have the name, the Twitter, session type, or speaker type, talk title, bio, etc. And this is great, but it's only a static tabular set of data. How can we add some interactivity with it? Well, with Google AppScript, we can add side menus. So here I've created a little button which will pop out the side menu. So we'll actually see that on the right-hand side, we'll see contextual information, the GitHub profile photo, and other information about specific users that we're highlighting. We'll actually even get the top result from the YouTube API and show it right here in the side panel. Cool. So how does that work? Let's show some of the code. So first, let me show you this tool called Clasp. Clasp stands for the Command Line AppScript Project tool. It allows you to upload projects, download projects, etc. So here I have some sample code. And here I'm just declaring a function called sendMail. And we're saying in the first line, Gmail app.sendMail. This uses the Google Gmail API. And in one line of code, we can send an email. So let's actually try to do this right now. So cool. Cool. So what this is doing in the background is we're actually we have a node binary here called Clasp, and we're communicating to the AppScript API, which then makes a request to Gmail's API to send an email. And if that's all successful, we should see an email sent to Jules and Keith, the PM of AppScript. So let's see. Cool. So we've just sent an email just 0 minutes ago. We can also do other things, like, for example, searching YouTube videos. So let's say I am doing some analytics and would like to search for the top 10 YouTube results programmatically of the query Angular Connect. Well, from AppScript, we can do that pretty easily. So, for example, we can just search top YouTube videos here. Let me first run the demo. And we can see we have a list of the top 10 YouTube videos. Just to confirm, here we see, that's actually me. That's quite funny. Wow, what are the odds? Okay. So just to explain the code a little bit, here we're declaring a function, and we declare var videos, and we search for specifically the ID and the snippet of our YouTube videos. We provide the query Angular Connect, the type of video instead of a playlist, for example. And then we just want 10 results. And then for each of these items, we just log the output. And so this is actually what's the same function that's populating this little dialog below, except in this one, we're just getting one result. It would be great if Jules and Keith were around, but no worries. So in summary, I showed you how you can use Google Sheets, and you can create custom side menus in the 300 pixels on the side of Google Sheets. And you can build a custom web application that can connect to APIs like YouTube's API, GitHub's API, etc. So you can select whichever row you'd like, and you'll get live results on the right-hand sidebar. The beauty about this is that you don't need to worry about hosting any of your code. It all lives within Google Cloud, and any user that has access to the spreadsheet has access to your application. So we integrated with GitHub, Gmail, and Google Sheets, as well as YouTube's API really quickly. So one of the advantages of AppScript is that you're able to write API calls like this without having to worry about any OAuth or server-side credentials. OAuth is built into AppScript, and so you don't need to worry about managing if your application has authenticated with this API or not. Here we're just searching for a snippet and getting the videos back. And then I actually haven't shown this part. So let's say you'd like to convert this file into TypeScript, right? And run it on Google AppScript servers. Well, so to do that, there's simply two things. One is you rename your file from .ts to .js, and then you'll see there's some errors. To fix that, we can simply go just install the types from npm. Great. And well, this variable should be in a different file, so it should resolve. And when we actually push to the server, we're going to be transpiling the TypeScript into Google AppScript. And so we could immediately invoke the function. So let me just run the sendMail function again, and hopefully, okay, Hopefully things will work, but maybe not. Okay. Cool. And to just use TypeScript with Google Apps Script, all you have to do is import Google Apps Script in the beginning, and then you can get all this auto-completion. For example, sending emails is really quite simple with Apps Script. Cool. And once you are able to send emails, you can actually so you can execute commands from the functions from the command line, and even view Stackdriver logs. Ideally, we would have woke Jules and Keith. They're in US Pacific. So that's it. That's Automate G Suite with AppScript and Angular. My name is Grant Timmerman. Feel free to ask me any questions, but thank you so much.
Thank you very much. We're going to take a 5 minutes break. And we have Elana in track 1. Then in track 2, we're going to have Juan. And then there's also office hours. So we'll see you back in 5 minutes. So, welcome back, everyone. I see that it's really, really crowded here. So I just wanted to let you know that we are streaming in the games room as well. And apparently today there's also audio that comes with the streaming. So, yeah. So if you think you're more comfortable, like sitting from the chairs there or the beanbags or whatever they have there, then you're more than welcome to just hang out there. Right, so without further ado, I just had the pleasure of having a very nice chat with Juan. He's a lovely, lovely speaker and person. He's going to talk about dynamic reactive forms, which I know are quite a handful to handle in your applications. I think it's also your first bigger talk, you told me, right? So I would really encourage you to give him a big hand of applause, because when you're a first-time speaker, that really helps you a lot. So please welcome Juan.
All right. Thanks, everyone. Is everyone here? All right. So I would like to start asking 2 questions. Please raise your hand if you have ever used reactive forms before. Yeah? All right, good number. And please raise your hand again if you have ever used dynamic component loaders, the technique of loading that components dynamically. Okay. All right, I'm going to be talking a lot about those 2 techniques in this talk. All right, so my name is Juan Stopa, and I'm a software engineer at Wealth Dynamics. And today I would like to talk about one of the biggest challenges I face while building software for the enterprise. And as easy as it sounds, the challenge is building forms. But why building forms for the enterprise is such a challenge? So first of all, capturing large amounts of information. If you think about the process of applying for a mortgage application, there's so much information that you need to capture, and someone needs to physically type in that information. And then we have, complex validation rules, and the validation rules keep changing all the time. So most of the forms that I've seen out there needs to be rebuilt every time that the validation rule changes. So then the requirements tend to be very vague. To give you an example, GDPR came into effect this year, and companies are still trying to figure out, what information they need. And finally, the designer tends to get very creative with mock-ups and how forms should be. And there's nothing wrong with being very creative, but not always follow the best practice of the UI framework. So today, I'm very excited to show you a framework that I've been working on in the last few months. So this framework attempts to fix all the issues that I talked before and bring a scalable solution to building forms. You can also use this one for any other type of application. But anyway, I'm going to go ahead, and this form uses reactive forms. It uses dynamic component loader, NGRX, and GraphQL. And I call it FormQL. So and I'm going to give you a quick demo on this. So here we have a form. So just so you understand, this form, the definition of this form is a store in the server in a database in the JSON format. This JSON is downloaded into the client, and the client renders the form programmatically. And of course, since I use NGRX, I have a store with my information. So if I type information here in, my store will get updated, as you can see. And then if I put some other information there, the store gets all the information that I get. So there are 2 things that I want you to understand from here. Is every single field in this form is a component that has been loaded programmatically using the dynamic component loader. And then the other important thing is the store here. It has 3 objects, I will call it. The data object, that is where from the information that you type in the form is stored. The form object, that is the definition of where all the fields are located in the form. And then the component, which is a normalized list of all the fields and its property. So there is another thing that I can do in here. I'm going to just put an ID of a record, for instance. And here, the information got loaded into the data and then populate into the form. But I'm going to come back to this one later. So here is a more graphical representation of what happened there. So you have a layout that tells you or format gives you the definition of the main form. Then the layout can have pages in case you want to have in your form multiple tabs. And then each page will have multiple sections, and the section can have multiple components. So it's basically a tree structure of that. And then you have the form group, which is a property of the reactive forms. And it's an identical tree structure of the form metadata. So for every level in the tree, you have a form group that will assign. So you will be able to calculate the validation or validate that component at that level of the tree. So something very important to take into here is that the store dictates the validation rule with a new state. So that's in the form metadata is stored in the NGRX store or Redux store. The form group lives at the component level, and it just takes all the validation or the new state from the form metadata and applies the validation rules. And let me, all right, sorry. So that's all good. So what we have so far is a framework that allows you to set some sort of a JSON that gets downloaded into the client, and the client programmatically set all the fields on the form. So what about if we want to modify this form? So one way could be just, we log into the server, grab that JSON, put it into a form editor, and start fiddling with it. But you don't really want to do that. That will be really tedious. So for that, I created a form editor. So I'm going to give you a quick demo on that too. So in here, I go to my form. I'm going to just add the word edit at the end. So this one, just to specify, I created this route specifically just to input parameters into the main component in the form. So and this is the editor, right? So what you can do here is, for instance, you can drag and drop fields around, right? Like that, for instance. You will notice here the action that are going into the store. I'm going to save it. Let me just make sure that I save it. And yeah, I have a save action there. And then if I load it, you see, the fields get populated. So it's definitely real, So I'm just going to move this one back because I need to using this one for the rest of the talk. Oops. Right. All right, cool. That's good. All right, so how the form is loaded? So how is the initial load? So an action is sent from the form QL component into the store. The store, using side effects, loads the initial store, basically the initial state, sorry. The state then is sent back into the form QL where the form groups applies all the validation, and then the components are rendered. So the same happens with changing the states. So what we do here is a keystroke is detected, or it could be a drag and drop, and then all the store revalidates or recalculates the state. A new state is sent back into the form QL component. The form group again, recalculates the state and send a notification to all the components to only the component that we want to modify. So what we've seen so far then is a framework that allows you to, in some ways has two modes. A view mode that is all about editing data, and an edit mode that is all about editing form metadata. But there is another mode that is really important, really useful for building forms. So what do you normally do when you're building form? You will probably start with a state, with a model, or defining your data model. Your data model then you will probably create a table on the database, and it could be, or it could be a document, or it could be columns or properties, and then we will decide this is my data, and you will store it there, and then just move into the client and into how you can get the user to enter this information. So it will be really good if you can combine these together. So in the sense that you can edit the data and the metadata at the same time. So that's what the live edit mode is about. You can edit your data and your form metadata at the same time. I'm going to show you a demo on that too. So in here, in the root, I'm just going to put the ID of the record I was using, and I'm going to put the live edit mode. So you can see here now that you have the form with data, and you can do the same thing as I did before, the same properties. So one thing here, the data source of the form, and here's where you can define your GraphQL query to download your data. So this, in here, you can pass your ID, and then define all the fields that you want in your form. I couldn't get the ACE editor just to put it nicely formatted. But in here, so you will get all the properties that you want, and then you have the mutation, which you can pass an object from the store, and then do the mapping. So this will be when you hit the save button. So it works in the same way. So that's one of the main property. Then you have here all the things if you want to add a page, section, or component. And then the important thing is also if you want to edit a component, you will you can go here and and modify your label if you want. Here's the name of the component that I'm loading programmatically in the background. And then you have the properties, and that's the very important thing is the data mapping. You have a component that contains a field, and you want to map that field into something in the store. So in this case, is the first name, right? So in some ways, like subscribing to a property in the store. And then we have the validators. And here's where the beauty of I would say, comes. Is you have the calculated field is when you want to calculate an act. Well, let's say that you want total in your form, right? You can calculate an expression. That expression is going to be calculated against your store. I'll show you later an example, I think, that will make it more clear. Then we have the hidden condition, read-only condition, and required condition. So this is a condition, again, that is calculated against the data store, and you can tell it when a field is hidden, when a field is read-only, or when a field is required, right? And you can also add your custom validator if you want. So for instance, here I'm in the first name field. What about if I want to make this field required? So I can just put true, just as a condition, static condition, and just say, please enter first name, and save it. And then you'll see here that the field is required now. If I remove the data, that becomes required. But then you can do more complex things, like for instance, what about if you want to hide the mobile phone field if you haven't entered the first name? You can say, well, contact.first name and negate it. So in that way, if I remove this one here, then this field will become hidden. I just put an icon here, and in edit mode, I'm just not hiding the field because I want the user just to be able to do. But if I save this one, did I get my action to save? Yes. So then I show it into here. Right. And I'm going to remove that. You see, the mobile field is gone. So if I enter some data, it's coming back up. All right. That is... All right. So that's all good. We have a framework that allows you to to modify, to create forms and configuring. But what about if you want to extend it? What about if you want to create your own components, or you have a designer that comes and say, I want to drag and drop a functionality in the form. So that's something that FormQL will allow you to do. So here, for instance, I have, again, it's the app architecture. I have the component and all the components involved on the framework. So just notice that the layout and the components are loaded programmatically using Dynamic Component Loader. So, and something that I didn't tell you is that FormQL, in this case, is a library that has been imported into an Angular app. So then you can create your own custom layout and your own custom component, and they can be loaded programmatically. So and that's really powerful, because then you can extend your application without breaking your main framework. And of course, I mean, the component that we create, they will need to be, or to adhere to some sort of a input parameters, I would say. So in this case, you have a custom component. So I can just call it my custom component. The component name is something that you will need to also put the name of the component. This is the case if you build a production build your Angular app, the name of your component will change. So that's the way to still identify it. And then you have validators. In here, you can put custom validators if you want, or you can put the existing reactive forms validator. Of course, you need to implement the control value access, or that's something that you need to do for to create any field, any custom field in reactive forms. So then we have an input that is a field, and you also you get the form group, which is basically when I took in my level tree-level structure, the component level. There's going to be a form group, and that will allow you, to be notified for changes and that sort of stuff. So just let me give you another demo on this one, on how I use a dynamic component. So if I go back to my form, and I'm just going to make this one a bit bigger, I have another form that I created that I call it mortgage application. Right? So here, let's say that I'm a client or a prospective client that wants to apply for a mortgage application, right? So I'm gonna here start, putting my details. And here, so before I continue, is, sometimes I kind of understand design when they come with these, creative or funny, we'll say funny mock-ups. But completing a form application or a mortgage application is really boring. So you really want to get the user in some way, or the client engaged when you are filling up your details. So this is something that will allow, so the framework will allow you to do. So let's say that I'm applying for a £100,000 mortgage, right? And then, as you can see here, you get the total payments, which is calculated using the calculated field that I showed you earlier. Then I will say I've got 25 years is the mortgage period. And then I managed to get a 2% interest rate. So you can instantly show information to the user. So these two components, or these two graphs that you can see here, they are actually custom component built outside of the framework. And as you can also, if you want, let's say that I wasn't that lucky and the interest rate is a little bit higher, then you instantly can see your mortgage amortization and all data. Or even if you are, you wouldn't go with that, but let's say, I don't know, 3%, and then still, you get the same amount of information. So I think I've got a bit of time here. I'm going to show you how this one works. So if I go into the edit form of this form, in here I've got my app chart, right? And my data mapping is again contact. So I want the contact object to be notified when the whole contact object is changed. And then you have the custom config, which here is a model that lives in the custom component. So in here is where you can put the data that is going to map against your object. Hope it makes sense what I'm saying, but that's the way that you can keep extending your component without still using the framework and extending it outside of the framework. All right. Okay, so what's next for my framework? So what I'm really intended to do is just get feedback. If you guys can grab me in the office hours or just you have my Twitter handle there if you want to just tell me what you think about it. I'm planning to do some other stuff on this and I just want to get as much feedback as possible. I'm planning to integrate the Angular Material CDK. It's all the cool feature that it brings now. For instance, now we have a drag and drop, and that's something that I will definitely try to be using. I want to put support for RESTful APIs. GraphQL, I think it's great using it with GraphQL, but I don't want to be limited only to GraphQL. And also, I know that the Apollo people are doing a lot of work for the Angular community. That's what I heard on Facebook. So I think they are intending to create a store where you can put all your information from the GraphQL queries. So that's something that I'm going to be looking at. All right. So and then the conclusion is, so reactive forms are really good. If you don't use them, I really recommend it. It really helps you to have your form in an immutable state, and you can only, you only safely change it by sending action or modifying it from the form groups. The dynamic component loader is something. It's a technique that I've used it in a lot of applications, even in production before, and it works really well. So you basically create your application or your core of the application in a separate package, it could be, and keep extending it with with components that are loaded programmatically. And that's, you can try components that work well, then you can probably throw it away and then just get another one. And, that really extensibility is what it allows you to do. So, and then the NGRX is one source of truth. I think is great. I think there is a lot of people that think NGRX is probably I overheard that the NGRX could be sometime sorry it could be. So if you have you don't want to use it for every single case. I think there are in certain cases that make sense to use it. In this case, I just find it great to use it. And the GraphQL, you don't want to be downloading all your data from your APIs, or you build an API and start adding attributes, because as it happens, you need your API for completely different things. So in GraphQL, at least you can cherry pick your data and say, this is what I want in my fields, and I can change it whenever I want. And there is something that I always say, it is very important to innovate when you are building web applications. And there is no silver bullet solution to solve all the problems, So I strongly advise everyone to use the technology that works best for you and your team. All right. Thank you very much. All right.
Thank you. We're going to have a short 5-minute break. Please check the schedule, pick your talk, and yeah, we'll see you back in 5 minutes.
Why is this frozen?
Hi, welcome back. We're gonna go ahead with our last talk before the lunch. So next up we have Manu. He leads the technical program management for Angular at Google. He's the one who keeps the big picture in focus. And today he's going to talk about the life of an Angular pull request. So please welcome Manu.
Great. Hi, folks. I'm very excited to be here today and share with you some of the process improvements we are putting in place on the Angular side. Partially because it's going to help my team and myself, and more importantly, because it's also going to make your experience with Angular better, and also enable you to get your issues and contributions addressed in a more efficient manner. A lot of what I'm going to be saying today and talking about is not very Angular specific. These are good practices and things you can actually use on your other projects as well. So a bit of an intro about myself. I joined the Angular core team at Google in October 2017. I lead technical program management for Angular. And I'm passionate about full stack web development, agile, and lean methods. That's been my area of focus in the past, and the ones that I'm passionate about. OK, Angular, 1,419 contributors. We almost have 600 releases so far, 1,900 commits, and slightly shy of 30,000 closed issues, and 19,000 pull requests. And that's only framework, material, and CLI. I haven't even counted all the other repos that are part of the ecosystem. So let's put that in perspective. What that actually translates to is we do 4 releases, 127 commits, and 122 pull requests every single week. That's pretty amazing. And it also highlights the fact that managing an open source project is hard. Managing a popular and high-velocity open source project is harder. Successful open source projects, and all good products in general, have the following attributes in common. They all start off with a clear vision. You have been hearing about new capabilities with Ivy, some of the new use cases that Ivy enables, built like Google with Bazel, and a lot of coolness that's coming out that's on the horizon. Good products also have a sustainable process and execution strategy so we can realize the vision, rather than just rely on best intentions. Lastly, perception is largely a byproduct of how well we do the above, of how well we execute the vision and have the supporting processes to actually realize it, in addition to other things such as community and documentation that contribute towards the overall perception of the product. So my talk will focus on the process and execution piece. It's a topic that I deeply care about, and it's also very important as Angular grows as a community. I want to make it easier for you to get your issues resolved and be able to contribute to Angular. Specifically, there are 3 things that I want to talk about today: issues, contributions that culminate in pull requests, and how it all comes together through the development process. Those are 3 things that I want to talk about today. Process is one of those things we strive to continuously improve. We definitely have a lot of work that remains to be done. But we've made great progress, and it's mind-blowing to see how far we've come along the last few months, especially. So I'm going to approach each of these areas from 2 angles. One is I'll talk about improvements we're making to each of these areas, and then I'll also provide you some insight into the process. All right, let's dive right in and talk about issues. So I've found a bug. So how many people here, I'm just curious, have actually filed an issue report with Angular? It could be a bug report, it could be a feature request, or anything. OK, I have a few people there. So I found a bug. I need to go to production with my application in just a few weeks. The pressure's mounting. I just updated to the latest version of Angular, and I've run into an issue. In panic, I head over to GitHub, quickly type up an issue report. I also cut and paste 15,000 lines of my production application code into the report and submit the report. And I keep my fingers crossed, hoping that somebody from the community or the Angular core team will actually be able to look at it and help me out. There's more than one thing wrong with this approach, and with this report in particular. You'll also notice that I've logged the defect in the wrong project in CLI instead of framework. That's one thing that's wrong about it. But more importantly, the biggest thing that's wrong about this is that it is not actionable and will most likely get closed by the reviewer. So the point here is that putting time up front and doing some due diligence will really help us help you. So what are some of the things that you can do, and how do you create a bug report that developers will love you for? So the first thing you can do is to do a search on GitHub to see if the issue has actually been reported. By default, and I have a little screen capture here, GitHub looks only at the open issues, but it would be in your best interest to expand your search to the closed issues as well, because sometimes you may find valuable workarounds, known problems, and other useful commentary in those closed issues. So it'll really be in your best interest to take a look at that first. If an issue is already open, please don't duplicate it. Instead, add any pertinent information to the issue. That's just going to help us get to the bottom of the problem faster. If you don't find an open issue, or if your issue is different in scope, let's say it's got a larger scope than what was previously reported, sure, it makes sense for you to proceed and go to the next step. Second thing you want to ensure is whether it's really a bug. It's actually quite surprising. Many a time when I think I've found a bug, I only realize that it was a user error or a misunderstanding of the capabilities on my part, or even an environmental issue. So you want to really make sure it is a bug. And if you're not sure, we have some helpful communities. So you can go on Gitter. There are about 17,800 people, a lot of useful members, a lot of very helpful members on Gitter that answer questions and stay active. Use the resource. Alternatively, you can ask on Stack Overflow as well if you're not really sure and want to get validation before you go ahead and log the issue. The third thing you can do before you actually file a bug report is to create a minimal reproduction of the issue. So this will help crystallize everything before you actually spend the time writing a bug report. So we just released a new Stackblitz template for you to create a minimal reproduction. In fact, this was released, I think, a day ago. So if you go to our new issue templates, you'll find this link from there. The template is actually pretty simple. So it's a single component, inline markup, use basically inline markup with a single template. Also in the index.html file, we have a few things for you to fill out. So two things we ask for are step-by-step instructions. I filled out this text box, I selected this value from the drop-down, I click on Show Me, and I get this error. So very specific instructions that will enable the reader to sort of reproduce the issue. The second thing we also ask for is the expected and actual behavior right in the template. Right? So you see your reproduction, and right below it is the actual details of the error. Right? The index.html file also has some general guidance in terms of what constitutes a minimum viable reproduction. And that basically means code, markup, and styling absolutely required to reproduce the issue. In other words, every single line of code you provide must be executed to be able to reproduce the issue. That is a minimum viable reproduction. The template should work for the lion's share of the cases. If not, feel free to extend it, but I think this should work for most people. This is just the instructions in the next file. You would basically delete the general guidance and put in the information that we ask for. OK, now you're ready to create a bug report. Like I previously mentioned, we used to have one-size-fits-all, basically. It was one template where you would go and essentially create a bug report or a feature request or what have you. So a day ago, we took advantage of this new capability, and we released this new set of templates that essentially provide a more intuitive experience for you, and we can ask for relevant information depending on what you choose. Right? So this will also help process the issues more efficiently for us. because what we ask for a bug is quite different to what we ask for a feature request. So this will help in that regard. OK, so you've done your due diligence. You've created a minimal reproduction. You've logged the issue. What happens next? So we actually go through a two-level triaging process. And triaging basically means we categorize and rationalize the issues so we can focus on the most important work. So we go through a two-level triage process. We assign a bunch of metadata that helps tell us which component the issue is related to. What's the type, severity, and frequency, and what have you. So once triaged, the issues actually get on a backlog, at which point they're ready to be scheduled to be worked on. So this is the backlog of the issues, where we compute a priority score, that's the leftmost column, based on the metadata we use in the triaging process. And that's where the issues basically land up once we triage them. OK, moving along. So that's the first thing I wanted to share with you about issues. And then now I'd like to switch gears and talk a little bit about contributions that culminate in a pull request. So giving back to the community that we take so much from, right? Contributions don't just have to be code. I want to get that out of the way. So improving documentation, answering a community member's question, giving somebody a workaround are all perfect examples of fine contributions, right? So these are all contributions that help make Angular better. So why would you want to contribute? It's empowering. You're making your life better and the life of others better as well, and you're influencing the product quality and the roadmap. You advance your skills. You get valuable feedback on your code and artifacts from some of the best minds on the planet. You also build yourself an awesome profile, right? So good work gets noticed pretty quickly. You can find a mentor depending on what your advancement goals are. We are a large community, you can find a mentor. And you can be a mentor yourself. So being a contributor is just gratifying. So there are some contributor artifacts that I quickly wanted to point your attention to. The first one is the README file. That's a good starting point, especially if you're new to contributing. It welcomes new members on how to get started and helps you figure out how you find your way around Angular. There's also a document called Contributing, and all of these documents are available at the root level of the repository. This contains more information about the processes and artifacts to be aware of if you're a contributor. For example, we have a contributor licensing agreement and talks about things like that and other things as well. Code of conduct, this was mentioned and highlighted in the keynote as well. I can't stress this enough. We live and breathe this every day. We take it very seriously. It hinges on our core principles of respect, integrity, and fair play. All communications on GitHub are subject to a code of conduct. And like any virtual communication medium, before we react, we should consider possible interpretations, language barriers, and so on. So that's always a good thing to keep in mind as we communicate virtually. So Igor in the keynote yesterday also talked about excellent interactions, and we strive for excellent interaction in every single touch point we have with the community. We also have other supporting resources on Angular.io where you can get information about how we do our releases, a release cadence, long-term support. So you can get a bunch of other information that also will help you with your contributions. OK, GitHub also has two other labels. One is a good first issue, especially geared towards first-time contributors, and then help wanted. These are issues that we explicitly ask for help. We haven't been really good about using these, but we're just starting to. So keep an eye out for this. And the nice thing is this is integrated with GitHub tooling. So this should show up on your user dashboard or the search pages or topic pages. All right, so your contribution culminates in pull request if it's a documentation or a code contribution. So at this point, your changes will get reviewed. Any potential modifications will be discussed with the reviewers. Follow-up commits will be made as necessary. So what happens after you submit a pull request? We go through a similar triaging process that we have for bugs, except the metadata we use is a little bit different because it's a pull request instead. And once the pull requests are triaged, it actually gets on the backlog just like we do with bugs. I also want to call your attention to two validations that we do with pull requests. It's kind of been a black box, so I just want to shed some light on the couple of things that we do with respect to validations. So one is, we have continuous integration through Circle and Travis CI. So linting, type checking, we build, we run tests that we have written, and really the goal is to surface any problems before you run into them. That's really the goal of that CI. In addition, we also have a Google validation step that you might have seen on the pull request detail screens. This is where we actually validate the changes you have made against Google applications. And this helps you get your first real validation in the real world. How cool is that? That's how a typical triage session on the Angular core team looks like, and that's Mishko sitting right up in the front. He needs no introduction. This is a dedicated time where we lock ourselves in a room and we look at issues and PRs twice a week, and we do it every single week. The other thing we also have done is to get some automation going, because a lot of this triaging entails going through a workflow of activities. So we have developed a Probot-based GitHub robot to automate some of the manual tasks. So it triages PRs and issues by assigning various milestones that helps with the workflow and helps move things along. It also performs various checks on the PR and updates the overall merge summary status. And it also computes size changes resulting from a PR. So you submit a PR, it compares it with the baseline that we previously know from the master branch, and reports if your change will actually increase the overall size, if it's going to decrease it, or if it's going to keep it unchanged. So it does all of those things and really helps us out as we put this process together. Okay, so we've looked at how issues and PRs get triaged and make it to a prioritized backlog. What happens after this? So the product backlog is comprised of the bug backlog that we talked about. It's also comprised of the pull request backlog that we talked about, which gets prioritized. We looked at that. And then we have release level features, technical debt, what have you. So all of these things get into a product backlog. They get rationalized, they get groomed on a weekly basis. And we run 2-week sprints. So at sprint planning, we look at the product backlog, we look at the topmost priorities there, we look at our velocity, we bite off a chunk from the product backlog, and we essentially do our sprint planning based on that, where we do a task breakdown and we execute on them for 2 weeks. We also have daily stand-ups, and we also have mid-sprint check-in meetings. We have that cadence going on. And the sprint results in a potentially shippable release increment. And we conclude the sprint with an end-of-sprint review and a retrospective. Like I said, we do this every 2 weeks, and then we rinse and repeat. So in summary, and I'd like to keep this short, I hope I gave you some insight into the process we use for Angular, for bugs, PRs, and some of the improvements we have made, which will hopefully make your experience better. There's more work to be done, and it's one of those things we continuously strive to improve and iterate on. But I really feel good about the progress we have made thus far with the whole process. Now, we have this in place. Numbers are not going to change overnight. We will keep executing on this over a period of time, and then we should actually start seeing the counts drop. But we have everything that's needed to actually make that happen. And if you have any feedback, suggestions on things we can be doing differently, any pain points you have, or how we can make things better, come see me at the conference, or you can reach out to me on Twitter anytime. Definitely would love to hear your feedback. Thank you for the opportunity, and have a great rest of your conference. Thanks very much.
So yeah, I just had to double check if it's lunch break now or not, and it is lunch break. So Enjoy your lunch, and see you in a bit.
Hello and welcome back after lunch. So there's not so many of you in here, but I think that we've got a challenge with track 1 to see who can make the most noise. And I think even with just the few of you, we can make the most noise. So I want all of you to stand up now. Up, up, come on. You've all had lunch, so you can get up. Okay. Let's start with some star jumps. We're going to do that? No, okay. Let's start. Okay, so what's going to happen is, when my hand's down like this, you just want a quiet sort of clapping, okay? So just sort of a patter. So let's start with a patter of claps. Patter, that's it. Very good, okay. Then as my arm rises, so should the noise, okay? So let's hear. That's it, good, good. Yes. You can make some noise, verbal noise as well. Some yelling, come on, some yelling now. Woo! Okay. Very good. No, don't stop. Don't stop. Don't stop. Keep going. Keep going. I'm not sure whether they've heard us next door because I can't hear anything from there. So what we need to do is actually do it so loudly that they are going to feel jealous. Okay, you ready? Okay. Getting louder. Getting louder. Wait for it. Wait for it. Come on. Come on. Very good. You can sit down now. Okay, so while you're sitting down now and all woken up, if I can ask you to get your mobile phones out. I'm assuming you all have mobile phones. They're all connected to our Wi-Fi. And if not, that's at the bottom of your lanyards. What we want is your questions for the Angular panel at the end of the day. They're behind, you know. They heard us. They're not as loud, obviously. Okay, go to that website, sly.do. Enter the code Angular Connect. You should be doing this now on your mobile phones. And then when the website loads, there should be an Angular panel option at the bottom. And questions, that's where you can submit your questions to the Angular panel at the end of the day. Okay? And any feedback as well. Thanks, Megan. Okay, so I'd like to welcome Yunus to the stage now. He is the creator of Wishtack. In his spare time, he contributes to open source projects, meetups, and online shows like Angular Air. Today, he'll be talking about how to architect your application to support A/B testing and other customization. Let's hear it for Yunus.
Hello, everyone. Try and turn on my computer. Okay. Okay, good. So, did you all have lunch? Okay, no? Okay, did you have coffee? Because we're going to need some. So, my name is Yunus, and I'm the creator of Wishtack. I'm going to tell you more about it later. So I've been extreme programming since like 10 years. So moving from web development, creating stuff, to web security, breaking stuff, then back creating stuff, front end and back end mainly. And so Wishtack was created like 5 years ago because I created that with my friend Lionel, who's not here today. And we created Wishtack because I was looking for pleasure at work and freedom. So it was the only company I found which really made that possible for me. So what we do at Wishtack, so we have a social shopping application. It's not what I'm going to talk about here today. But we do trainings from web development to extreme programming and security. We also do consulting and extreme programming coaching. And we do consulting sessions, a special thing we do. Like if you have any question or you have any things you want to solve with Angular or anything, you plan a session with us like an hour or two and try to solve that together. So today I'm going to talk about A/B testing, canary release, and white labeling with interchangeable components. So does A/B testing ring a bell? Do you know A/B testing? Can you raise your hands? Okay, cool. So let's skip that. Canary release, birds? No. Okay, it's or progressive deployment, maybe. Something that talks more. And white labeling. Is that? Okay, good. And interchangeable components? Really? Okay. Good. So, okay. So this is a story, which is not totally real because I had to change it because it actually happened in a bank. And banks are not very funny, so I tried to make it turn into something different. So it all starts with AB. So AB is our product owner. Okay. So she came up with an idea. She has ideas like all the time. So her idea was like, I want an application to find conferences around. Original. So okay, we can do that. So we created this with Angular. Yeah, it's pretty simple, let's say. Okay. Problem is, at the beginning, AB was quite happy. She was like, oh, okay, that fits my needs. I like it. Clients seem to be happy too. But the problem is that we realized quite quickly that it was not the best user experience ever because you couldn't get the conference just in one click. So it was quite frustrating for users, some of them. So quite quickly, we used material chips to just grab the right conference start immediately. But then, so it was quite quick, but we couldn't release that because we were quite afraid. Do you know that feeling? Like, oh, I have the feature. It works, localhost 4200, but I can't release it. So we chickened out for two reasons. We were afraid that people wouldn't like this new approach. And the other feature, the other problem was that, you know that feeling when you're afraid that a small change like this would break the whole web? Yeah. So AB said, because she has ideas, so she thought that maybe anyone should be able to release new features like one by one. Like we develop features, but then we want to release them separately. So we thought maybe we can teach her some Git spaghetti. Do you know Git spaghetti? Cherry pick, rebase, squash, stuff like that. And then she said that she wanted to do that progressively on the audience, so we thought that Git wouldn't help us with that. And then she wanted to be able to roll back if necessary. So we thought maybe we could teach her some Git revert, but it doesn't solve everything. And she wanted to do that from home, like in one click, so you can roll back quite quickly, just from your smartphone or your setup. And we didn't want to do that. Go like, oh, this makes a lot of changes, but then I have this voice in my head from Kensbeck saying, embrace change, young man. It doesn't speak like that, but I thought it would be funny. So the team started thinking about things, and they were like, maybe we need A/B testing. I was like, but A/B is already testing the application. And then it was like, no, we need A/B testing on users. I didn't get that. Then someone said something about birds, I don't remember, and someone else said something about some kill switch. Well, I went back home, I went to sleep, and I started having nightmares. And the worst one was the kill switch, actually. So I couldn't even turn on the light to read stuff. So I waited the day after, and I started reading about A/B testing. How did they spell that? Okay, good. So A/B testing, I'm going to go quite quick on that. So it's basically you have two or more variants of some feature or application, and you just route part of your audience on the features you want, etc. And then you need the right metrics, business metrics mainly, to see which one behaves better and makes more profit in general. So you take the winner. And the idea is to make data-driven decisions. It's not about the feeling about what features sounds to be good. But now we're going to talk about canary release. So canary release, well, there are synonyms for that. Some people know it as progressive deployment, canary deployment, rollups, blah, blah, blah. And so the idea of canary release comes from, you know where? Coal mines. Like, so we used to use that, like you go into the mine with the canary, and if there was gas, then the canary would die. Then you would go out and grab another canary and try again. They stopped doing that. I think so. Well, anyway. So in the web, what happens is that it works a little bit like A/B testing, but then you start, like you have a new feature, then you route users to that feature, and you start first with like friend, fools, family, employees, and then anyway, you choose the right strategy you want. And you have monitoring So you want to know if things work correctly or if there are bugs or anything. And if everything goes okay, so you just raise the audience on that feature. And if anything goes wrong, then you roll back. Okay? So what's a kill switch? So the kill switch is, suppose you have some chat application like this, like live support chat, okay? And things go really bad with the backend. You don't want the users to start writing messages, sending them, and it just goes bad. You want to fall back on something else, okay? So you need a kill switch, okay? And the kill switch will just fall back, okay, to some other feature, some other component, some message or something, or just an email form or anything, okay? So we do that with the kill switch. Okay. So then, okay, we were trying to think about how we could set up these kind of things. And then AB just got there again with an idea. And she said, you know, like next month there's Angular Connect, and you know, Pete, Josh, and those people, Bonnie, they were like, oh, we'd love your application, but with Angular Connect branding. I was like, seriously? You know how it is. Well, so we thought about white labeling. So that's white labeling. It's just we do this a lot in banks in general. Like you create one app, but then you have different branding, and you sell that app to different banks or clients with different styles. But it's not about styles. It's also about features. It's also about the culture and things like that. Okay, and you might have different sets of features. Okay, so we started thinking about how we could manage to do that. So I came up with a weird idea I called interchangeable components. It's not micro apps. It's different. It's inspired from what we call interchangeable parts, like in the industry. You know, like you have two different, I don't know, fridges, and they come from different brands, but they have the same parts inside because they're built by different manufacturers, but they have some kind of standard, you know, like car wheels, for example, also are like this. So we need this for the web, like different components that have the same interface, so they behave the same way, they serve the same purpose. Here, for example, we had a component that serves one purpose, which is finding a conference, searching for one, okay? Searching for a topic. So they serve the same purpose. And they don't need custom fitting. You don't want to mess around with these components and be like, oh, if I'm in this situation, I'm going to use that component that way, blah, 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 you know. And the only way of doing that is that you have two or more different implementations that have the same interface, which is the same signature, and the signature of a component is not only, but mainly, its inputs and outputs, okay? I'm mainly talking about presentational components here, okay? Like low-level ones. So, okay, let's see some code about that. So it all starts with a classic TypeScript enumeration, okay? I love string enumerations. They're easier to serialize and things like that. And suppose you have some simple thing like this, like a configuration service, and this private method where you grab your configuration. So our app config is maybe some global variable that you injected in your app, or maybe you can use some API and grab that configuration later. Anyway, do however you want. And in the configuration, I have this string, this enumeration, which is the conference search display mode, okay? With a value that can be chips or form or links, like the different implementations we have. Then we have a map, all right? So we have a map that will map every enumeration to a component class, okay? Then we have a simple method that grabs the component, the right component class depending on the configuration. Is that fine? We could split that a little bit more into different services and unit test them separately or together. It's another subject. Anyway. So problem is, now you have a component. How do you inject that component in your view? Nobody was here this morning. Okay, gonna tell that to the guys. So the thing is that you usually use view container ref and you inject the component dynamically, but you have to clean up this thing later, and if you pass inputs, if you just set the properties, it's not very good, but because it does not trigger ng on changes, and you have a lot of trouble. So in Angular, you probably met ng component outlets, which is like native in Angular. Do you know that directive? It's a structural directive that will allow you, it will inject that component dynamically in the view. It will create it and destroy it afterwards. Okay? Is that fine? So if the configuration changes, if the component class changes, it's going to get replaced dynamically. So problem is, this is cool. Okay, it works. Problem is, we have some container components and presentational components at the bottom. And they have to communicate, mainly through inputs and outputs. Okay? Everyone familiar with that? So here, for example, my input is the category of topics I want to display in the list of links. And when the user chooses a topic, it triggers an event, topic change event, to the parent. Okay? Problem is, it doesn't work. There's an issue for that. ng component outlet doesn't implement inputs and outputs for the moment, so it might change. I don't know if it's going to change before IV or not. Anyway, we'll see. But there's some cool guy who created ng dynamic component, and it's not me. It's the real cool guy. Anyway, so ng dynamic component, what it does is that it just adds inputs and outputs to ng component's outlet. Is that cool? So you can pass inputs. It's different syntax because it's one input that contains all inputs, so it's an object. And you can grab outputs too. But be careful. You might have noticed I'm using an arrow function there. That's for not to lose this binding of the object. If you use a method, it won't work. Okay? Is that cool? So now the next step is that we're going to create an interface to describe this kind of components, okay? Conference search components. So this is the signature of the component. So there's the input, category string, and the output. And here you might be wondering why it's an observable and not an event emitter. Because Angular doesn't really care about if it's an observable or an event emitter. It's waiting for an observable. It's waiting for something to subscribe to, okay? And actually, you can create outputs which are not event emitters. So that's why it's more generic. So it works. And it gives the signature. It tells us, okay, how these kind of components work. And we can use that everywhere, like in our map. Okay? So if we use a component that doesn't have these inputs and outputs, then we'll have build time issues. So we ended up with something like this. So we gave an administration interface allowing AB to, or anyone else, to control the audience percentage and deploy these components progressively. Actually, the components are in the bundle, okay? But we control which one we use using like the slider like that. We could use other ways, okay? We'll see that later, the demo. So that's how we felt. Yay. But not for long, because then we realized that when you have a concept and you're very happy and you start overusing it, okay? So that's what we did, and we ended up with some active components, which are the ones that are used actively by the users, and the unused ones, those that are in the map, but never injected, because the configuration didn't load them. So you end up with some active components there, and lots of unused ones, which are still in the bundle. So we have a big bundle there. So how do we handle that? What do we need? We need lazy loading, but problem is, without IV, lazy loading is highly coupled to the routing, okay? So there are two solutions. We go in deeper with the Angular 6 and 7 and see how it works, or we can wait for IV, okay? For those who were at the talk this morning from Alex and Jason about IV. And if you missed it, you should definitely watch it, because that's the future, and the things I'm going to show you here are going to be, like, in the future compatible, or I try to make them compatible with IV, so it's going to be the smooth way to go there, okay? If you didn't watch the conferences, you can watch them on YouTube later. Not now, please, okay? So we came up with the idea of implementing a thing that we called reactive component loader. Okay? If you don't like the name, tweet me, because I'm really looking forward to change it, but anyway. So why is it called like that? It's reactive because we're going to be using observables, and we're going to load these components lazily as late as possible. Or not, depending on what we want. Okay? So first, it starts with describing all the modules, okay? Because we're going to put every component in a different module, because we cannot load components separately. We have to load modules for the moment, okay? And you don't want to put all the implementations in the same module, because you would end up with the same problem, because you load the whole module. So I'm going to zoom in, and this is how it looks. It might remind you of something, load children, okay? It looks a lot like a router. Actually, it's trying to hack the router low level. And it's actually creating a route there with it's linking the module ID we're going to use later with the load children. And we do this because otherwise the Angular build wouldn't build the daisy-loaded modules, okay? So, you see, so remember this. We have a module ID that will link to some module we load lazily. And then you have a reactive component loader service that allows you to load that component dynamically. You note that it's an observable there, okay? So we give it what I call a location. So a location is the module ID, is where the module is. And the selector, well, it's the component selector, okay? And you end up with a component recipe, okay? So the component recipe is not just the component type, it's also the ng-module factory, okay? We need the ng-module factory, otherwise the component wouldn't be found, okay? So ng-component outlet can grab it, we can pass it as an input, it's gonna use it. Now, it's still a little bit like tricky here, so we thought maybe we could make it a little bit more human readable. So why not just use the component location, okay? And we give that component location to a component called lazy. We give it the location, we give it the inputs, and we give it the outputs, and it's gonna do all the magic. It's gonna lazy load the module and grab the component and inject it. Okay? There's also a directive version of that. You get the point? This is the main thing to remember. So the thing is, the cool thing is that imagine if you have this lazy thing in an ng-for or in an ng-if, while the ng-if is false, the component wouldn't load. And when it goes through, beam, you're going to load the right component. Okay? Lazy loading, reactive. So that was quite magic, and AB was happy. So, but then we had other things to see. So first, you can, I'm going to ask you to grab your phones and computers if you want to participate, and there will be a demo, not right now, but just grab the link, and we'll start the demo later. I'm going to show you something. So, depending on your first name, you choose the version you want. You're going to see that later, why I'm splitting right now. Okay? And if you don't remember your name, it should be written on your badge. And if you don't have your badge, you can open both windows. Okay. So the links are at the bottom. Can you read them? Can you see them at the back? Is it good? Cool. So then, problem is, the whole logic is not in components. We have the behavior, and the behavior is mostly in services. So you might want to A/B test or canary release services. And we had this example, and so we had the buy button that would just follow some link and go to the right conference tickets URL. But then AB had a new idea. So AB thought, maybe we could just, like when you click the buy button, maybe we could add this product, this conference, to the cart. Okay? So different behavior there. And we want to deploy this. So we thought maybe we can apply the same interchangeable components concept to interchangeable services. Okay? So the idea is, okay, we have an interface for the service, a product behavior, and we have an implementation, like product behavior cart, which is the new one, okay, buy product, blah, blah, blah. And I want to use it, I can use it from the template, from my component. So I grab the product behavior, okay, this service, I inject the service, and I use it at the click button, okay? So if I have different implementations, I could switch at that moment, and I don't have to replace my components logic. Problem is, you can't swap services dynamically. You know, once the service is created, it's the same for the whole life of the component. And so we implemented, well, here for this example, a product behavior resolver, which is something that will grab the right service. So it's basically the same concept as for components. It's a map that maps every enumeration to the service class, okay? So then we grab the right class, the behavior class, okay? And problem is we have to create an instance, and you definitely don't want to create it manually. You want to use dependency injection, okay? So let's use the injector. Okay, so we use the injector, we give it the class, and it's going to create the instance, and then we'll get always the same instance. Okay?
Wait, don't you need to configure the injector beforehand?
No. That's the cool thing. You don't even have to configure that. The service just appears at that moment. Good point. And then the problem is you end up with the same problem as for components. We have all the implementations there. So same solution, we need to lazy load services. How? Well, this is tricky. This line contains 5 ECMAScript and TypeScript concepts, and Webpack concepts. We're using dynamic imports. So ES dynamic imports will grab the module dynamically, but with the CLI, actually, this will be converted to Webpack required. And Webpack will analyze the dynamic string we have there, see? And it will load the right service, which is the right class, which is the right module, TypeScript module, which has been compiled. And we can grab the class in the module. I just gave them the same name, so I don't have to create another map here to grab the right class. Okay? And guess what? You can use the injector. You give it the class, because the class contains all the metadata which is needed to inject services. And this works. So the service will be lazy loaded. Okay? So we're not using use factory or anything, we do it manually here. So, and the cool thing is that I love observables, so I don't want to use promises here, so I swap this and I turn it into an observable using the defer function. Okay? Just make it more reactive. Okay. Demo is going to wake up everyone. Okay. So the links, everybody has the links? Can you raise your hands for those who got them? Okay. Okay, good. Thanks. So this is the interface. And you should have something ugly like that. Okay? So I'm going to start with deploying the new, I'm going to create a new rule, configuration rule, and I'm going to create an audience percentage condition. So depending on my audience, I'm going to switch the changes, switch components. And look at this here, at the network traffic here. Okay? And I'm going to use the new lists component here and the new chips search component here. And I'm going to start deploying this. Does it change? If it changes, can you raise your hands? And if it doesn't work, you can pretend like it works and you just raise your hands. Okay, 30%. Oh. Okay. And you see, the module was lazy loaded. And now, if you don't like it, I'm going to roll back. Good? So this works for A/B testing, but it also works for canary release. So you can release some component progressively, add some analytics on that component when it's loaded, okay? And you analyze that on your favorite tools for analytics. And now, I'm going to remove that, and let's try white labeling. So some of you must be on wishstack.io, and some others are on Firebase, okay? It's the same app, but I'm going to add new rules here. I'm going to put them on top. work. The funny thing is that I had to implement drag and drop like 1 week before the CDK drag and drop. So it felt very fun. I thought it was a joke. Anyway, so here I'm making a new condition on the domain. It's going to be conference wish.io, and I'm going to give you 2 different configurations, because for the Firebase one is the Angular Connect version, so I'm going to put that. And they wanted a table, they said, and they wanted chips. Okay? Who's on this version? Okay. And now, for the other one, we just want some ugly stuff like that. Okay, because they didn't pay as much as the others. Okay. So now this was about white labeling. Are there any people on Android here? Okay. So someone told me just before that people on Android were more nerdy than iOS guys, and they love dark themes. Okay, I'm going to do that. So let's create a new rule here. And the condition is the device, it's Android. And let's turn it dark and add WishTag logo. And maybe the Angular Connect 2018 logo. Do you like it? You don't? Let's swap it back. Like it? Okay. Okay. And now, okay. But now iOS guys are jealous, aren't they? Okay, so let's turn it iOS. Oh, sorry. Okay. It's good? Or, okay, you know what? Android guys, I'm going to put something else here. Let's change the color. How ugly is it? Good. Perfect. Okay, anyway, why don't we just keep in touch? I'm going to share the links so you don't have to copy-paste them. And I'm going to disable this ugly thing here, maybe. Okay. Is that cool? You got the links? Thank you. And just one last thing I think. Okay. So I'm going to just explain quite quickly how it works. There's no magic there. There's no deep learning or anything. It's just AB, through the administration interface, we just create a configuration like this. We call it a rule. So a rule contains a condition, a position, and the configuration. Okay? And then we put that on, Cloud Firestore, Firebase, and it's synchronized like on all the devices on Angular. So we just watch that configuration and the rules, and we apply the rules. Okay, this condition is good, this not, this doesn't concern me. And it's an observable, so it keeps changing dynamically. Okay? So you don't have to do that because there are some tools for that. It's quite new for the front end, but it's coming more and more. And this is exactly the code that you have in the demo for that. Yeah.
How are you measuring?
I didn't do it here, but then you can add analytics. You can do as you want. So yeah, exactly. So you just put it, like for example, you could put that in on init, and you can trigger an event on Angular Analytics, and you grab the info. And so this is exactly how it works. So I'm using the async pipe, so the observable changes and the components will change. So the key takeaways, I'm going to accelerate a little bit. So the key takeaway is that inputs and outputs are the signature of interchangeable components. Lazy loading components is possible without Ivy using the WishTag Reactive Component Loader. It's the library we released last week or this week. And services can be lazy loaded too using dynamic import. So what's coming next, what you might need is what I've had to develop here is a custom feature toggle management. That's how we call it. And you might need tools for that. And there's a market and there are products around for that. Some are open source, some are more expensive, and some are free. And it's not a maybe. This is going to be easier with Ivy, okay? And one last thing, and I think this is the future. I believe in interchangeable web components. I'm not talking about micro apps. I'm talking about interchangeable components. So there will be small components that can replace each other having the same signature. And it's web components because I believe in a world of peace and harmony where we could have all the frameworks and libraries in the same app. And anyway, I've shared some resources on the slide. I'm going to release that on Twitter. And I put some links on the different tools you can find. So from the open source one to Launch Darkly, which is really awesome. You should try. And sorry, next time. And oh, OK, yeah, I didn't have lunch yet. And should go. So told you about that. And one last thing, if you visit our website, we share resources and guides like for Angular, Node, Python, and things like that, security. So go there. Some of it is in French, some things are in English. We have a blog you can check. And if you need anything, you can get in touch with us whenever you want, okay, through the website. Okay, well, thank you. And special thanks for all the people here and for all of you to be here. And for Shai, my speaker buddy here, and helped me a lot. So anyway, thank you very much.
Thank you very much. Okay, so we'll take a couple minutes break, and up next is Shmuela here, and that's the wrong slide. There we go. On track 1 will be Felipe. Did you already move it forward and then I moved it forward again? Yeah. Sorry.
No, you went back.
Oh, I went back. Oh. Hi. So welcome back. Shmuela's up next. She is a Google developer expert, a consultant, trainer, developer, and community activist. But many of you will know her as the founder of NG Girls, which does amazing work to support diversity in tech. Today she'll be talking to us about dynamic, get it? Okay, components, dynamic components. Okay, let's welcome Shmela to the stage.
Wow, hi everybody. Excited to be here. Okay, everything's working. I'm really excited to be here in Angular Connect again. I love this conference, and I hope you're having a good time. Yeah. All right. So today we're talking about dynamic components. So just and dynamic components it is. With Angular, who's using Angular? Okay, great. So I'm in the right place. Good. Okay, awesome. So Josh introduced me. And thank you. And so I don't have to say a lot about this slide, only that, yes, I love Angular. And pictures from a recent NG Girls event that we had. So let's start with the interesting stuff, demo. So we're talking about dynamic components, or dynamic components in this case. Does anyone here is anyone not familiar with this screen? Okay, great. No hands raised. All right, so this is the application that if you create a new application with Angular CLI, then this is the component that it builds for us, just as an example for what we can do. So is this a dynamic component? No, probably not. It doesn't look very dynamic. Now, if I click here, maybe, do you see this? This little thing? This is actually a color input. And now I can change the color. Wow. Is this a dynamic component? Well, no, probably not. It's got like changing the color according to the input, but that's it. OK, let's close this. Now, if I click here, is this a dynamic component? Well, it depends, kind of. Well, we'll talk about what a dynamic component exactly is. So it kind of depends on the implementation. But I'm sure you'll agree with me that this is a dynamic component, right? Very dynamic. OK. So dynamic components aren't really about the component themselves. You can write a component and use it dynamically or statically. But a dynamic component is the way that you use it. So I have another demo here that really has dynamic components, where I add a component, and let's make the screen a little bit larger. Oh, that's a Chevisaurus list. Wow. Who is this dino? And let's add another one. Anasaurus. Let's see a bit more. Oh, Maxosaurus Koretsky. So if you know Maxosaurus Koretsky, he gave a talk yesterday, and he's been a real help with my talk. He gave me, well, I actually based a lot of what I'm going to show today. I got a lot of inspiration from his talks from previous conferences and his blog post in Angular in Depth. Let's see who else I have here. Oh, Igor Sminar. He's also been advising me for this talk. And, oh, Unisaurus JD, he was here just a moment ago. And he also helped me a lot. And we've got a lot more. Oh, Ulisaurus Shaked, Asimosaurus Hussein, Michaelosaurus Ladki, wow, a lot of, ooh. Okay, so the way that these components are, well, so these are Dino components. Each one is a different component. They're dynamically loaded. I don't know which component is going to load. There's kind of a math random there. But they're not hard-coded in the template. Let's see what other component. Oh, a lot of components I have, dinos I have here. Okay. Let's see how. Okay, I think we've seen enough dynamic components. Let's see a few more things that a dynamic component can do. Well, these components also get the name of the dyno as an input, and we'll show later how to do this. And this is a bit more complex example of dynamic components, where I'm, again, adding components, whichever component that I want. And I want to show you here that we've got change detection and dependency injection working here, even though it's added dynamically. So it's still an Angular component, so I can change the name of whoever said this quote. This is me. And actually, no, I didn't say that. I said something else, like, oh, hi, Mark. Yeah, anyone? OK, I can add a graph. Let's add 2 graphs. They have initial values, but they have the values also connected to the rest, to their parent component. So that's why if I'm changing one value, it will change in the second one also. So there's also change detection connected, and the data is connected to the rest of the application. Okay? So these are great examples, but let's talk really about what dynamic component is and why we need this, because maybe you don't trust me that these are dynamic components, because these examples can be also implemented statically. So let's talk first about static components, what they are. And static components are components that are usually just used in the template. We're using their selector and putting them in a specific place in our code, in our application. So in this example, we've got several static components: the app header that I've created, and the tab set and tab that come from Angular Bootstrap, app node that I also created, there's an app dashboard, and so on. So these are components that I know where I use them. The developer knows when they use them, where they use them, in development time. And they're kind of they're in a fixed location in the template, and you can say that they're kind of hard-coded, but it's OK, because this is the way that we're supposed to use most of our components. Okay? But if you need to change them, to change the location, then you need to go to the code and really move them from one place to another. A great use case that we're having with lots of components is dashboard. Is there anyone here who hasn't been working on a dashboard in an Angular application? OK, a few lucky ones. Great. So let's say that you're developing a very generic dashboard. And you're developing all these types of components, types of graphs, tables, gauges, and so on. And then you and your team are developing tens or hundreds of different components, and the users are the ones who are going to decide what component is going to be shown and where and when, and with which data, right? And the users might not need all these hundreds of components. They might need only 5 types of them, 10 types, 20 maybe, okay? But not all the components that you've created. So if you're developing them in a static way, then you might have something like this in your code for every component that you have. So the user loads the configuration, which might be like an array of the components, and for each component, the component type, and then the data that they want to input into this type. And then you're doing an ng-for on this array, and you're doing an ng-switch to see what type of a component you should show. And then you hard code all the types of the components, right? So here you can see only 5 components, but imagine that you have hundreds of them. Now, there are several problems there. So first of all, who wants to deal with code like that, with like a really, really big template file? we don't, you want to deal with that? Really? Okay, you like to suffer. Okay, but most of us don't, and it's not a really great experience for developers, and it can break very easily. Now, you might say, okay, so let's split this code into different components, like let's do split the template to children components. But we've already done that. We can't split this template anymore. Now, another big problem that we have in this code is that our application needs to know in advance, in load time, about all the components, all the hundreds of components that we have. It needs to load them all and compile them all. And we've got a lot of code that we're not going to use. Our user is not going to use because the user will use only 5 or 10 types of components. So this is a really big problem that we have. So imagine, just imagine, in our very perfect Angular world, that this whole template of thousands of lines of code can be rewritten in only one line. What do you say about that? Okay, so in a moment we'll see how it's done. Let's talk about several other use cases for dynamic components. Before that, let's just say a few more things about them. So they can be added in runtime. So the user decides in runtime what component to load. We can load the configuration from the server, like I said before, or from anywhere else. Maybe generate it on the fly, like I did now. And they can be lazy loaded. So you can wrap each component in an ng module and build it separately and load this module only if you need it. So lots of code that is not going to be shipped unless it's needed. Okay? So these are the basics, but we're going to go over the code again in a few moments. So the main use cases that there are for dynamic components. So the dashboard, like I explained. Data-driven forms. So these are still a bit hard to do. There are several methods that you can do them, like configuration-driven reactive forms in Angular. But with Ivy, we're going to have a lot simpler method to load forms and form components, form controls, according to the form data that we have. But even without Ivy, we can still see what data we have in the form and dynamically load. For example, if the data in one piece is text, then it will load a simple input. If it's of type date, it will load a date input, and so on. So you don't need to load different controllers if you don't need them. Pop-ups and modals. So this is an example from Angular Material, and there are actually two dynamic components here. One is the modal itself, they call it the dialog, which they don't know, like they give you this dialog, this component, but Angular Material doesn't know where and when you're going to use it. And when you're going to use it, it can't be hard-coded in the template because it needs to be attached to the body element. So whenever it is used, you call a method that creates this component and adds it to the body, to the application, and removes it whenever you need it. And you pass data into it. And another dynamic component that we have here is the inner content of this dialog. So this is a component that you create by yourself, and you tell Angular Material when you're creating this dialog, you tell it what component to load inside. And this way you have only one dialog component with different components that can be generated inside. Okay? So again, dynamic. Another example is for content management systems. For example, a good example is Angular I/O. It is built this way. So they have several components, which actually, well, the application isn't like hard-coded with all the documentation, and probably you've also seen the documentation of the code itself, like the classes and everything that you have there. So it's not hard-coded. It reads the Angular code base and generates the views, the documentation according to it. Okay, so it just loads whatever is needed. If it's a code snippet, if it's several code snippets that need tabs between them, if it's an example, then it's all loaded dynamically. And then you can also write the content without HTML notation. You can write it in MD file, for example, Markdown. Another use case that I've dealt with, I was developing an application in Angular that is used for creating diagrams. And the diagrams are in SVG, and we were using another framework for that that's written in Backbone. Yeah, I know. Well, Backbone is awesome, but we wanted to link it to Angular with the change detection that will have dependency injection and everything. And the use case that we had, we wanted to have notes components in the diagram, where the note itself is an Angular component, where you can have the text, who has written this note, when, and you can also do some actions on this note, like change it or assign it to someone, and so on. So in this framework that's called Joint.js, they allow us to create HTML snippets and put them on their SVG elements. But if we want to connect them really to the application with Angular, and if we want to have an Angular component there, then we have to to load it dynamically and to also manage its lifecycle hooks. And for example, make sure that we call ng on destroy when we remove one of the components. A very good article about that is by Yuri Stromfloner, use dynamic components to render HTML for third-party libraries. He has a different use case there, but it has really great practices that you should use when you're doing that. Another example that I can show you is a plugin system. In this example, it's an application that allows teachers to create worksheets for their students, and they can choose from different types of questions. For example, we can see here a question where you can fill in the text or connect the dots. And there are different types of questions that they can use, and they, of course, put in the data, so like the text that will appear there, and then the students can solve it online. So the idea that the team had there is to allow developers from other teams, other places, other companies, maybe schools, to develop their own questions and to let the other teachers use them. So they will develop an Angular component. They will have the interface that we can use there, what inputs that we have, what events we expect, and they will develop it and ship us the code, and we'll add it to our application. And of course, these components are loaded dynamically, just like in the dashboard and in the other examples. Okay, another great resource about that is by Max Koretsky. He's given a talk, Modules Are Not What You Think They Are. You can search for this talk on YouTube. It was given in NGConf and also in NG Talks this year. So let's talk just a little bit about how components are created in Angular. So we have our ng module that wraps everything, wraps our components and directives and so on. So in the declarations, we need to specify which components belong to this ng module. And then we use this component in the template. That's a static component. So Angular recognizes that and compiles this component, creates a component factory, and then creates an instance of this component, which is a component view that has inside the DOM node and the component instance. And then it ships it to the browser that renders it. Now, this might change according to the compiler. It might change in Ivy, so don't rely on it heavily. But this is what happens generally in our application. So if we want to load a component dynamically, Angular doesn't know where it's going to be inserted and to which DOM node to connect it to with all the Angular framework that we have. Like I said, change detection, inputs and outputs, dependency injection. It doesn't know which injector it needs to use. So we need to add those components into entry components, and then Angular will know that it needs to create a component factory for them, but it will also create a host factory, which connects it to the surroundings wherever it is. And the root component that we have is actually also an entry component, but because it's there in Bootstrap, then it is already also given the same things that an entry component has. And you can check what type of factories Angular creates if you're inspecting your code. And sorry, this is really, really small. I'll get, oops, too big. Okay. So let's go to sources. And you have here ng and all the modules that Angular has created and compiled. So let's, for example, see the app module. So you can see app component ng factory and everything that's there, but we won't go into details of that, and this will also change very soon with Ivy. And we can also see that app component has an ng host factory. So that's the surrounding for letting it connect to the body element or wherever we put it. The same, well, the demo component is a static component, so you can see that it only has an ng factory and no host component there. But we also have the Dynamo modules, which have the component factories and the component host factories there. So you can see which component has what and how it's being used. Okay. Okay, so how do we do this? How do we insert the components? So we need a reference to the place in the template where we want to insert the dynamic components. So this is just one method to do this. I'm putting a reference VC, that's for viewChild. And then I hold this reference in the class as a viewContainerRef. Then when I want to add the component dynamically, I need to resolve its factory first, because Angular has created a factory, but I need to get it. So we have a component factory resolver for this. We also need to create then the instance from the factory with the injector that we have on this component, or maybe on its parent component, whichever injector that we want. And then we insert it to the viewContainerRef. Now, but this is the long version. Can you imagine that? It's only a few lines of code, and it's a long version. If you don't need to hold the component ref itself, then you can skip it and just create the component directly on the viewContainerRef. And then you even don't need the injector, because it will be added automatically. How do we pass inputs and outputs? Well, so then if we do hold the instance of the component ref, so it has the instance member on it, which is actually the instance of the component itself of the class. And we can connect to all its members and events directly as long as they're public. And so this is something we can do. But you need to know that in this, if you're doing it this way, then ng on changes will not be called when these inputs will change because we're not using the input itself. Okay, so, but you can still use ng do check. So I think you've seen a different method of wrapping it so that ng on changes will work. If you need it, then that's cool in the previous talk. What about content projection? Yes, we can do that. The content that you want to project will be added as a parameter to the instance creation. But still, if you've noticed, it's not 100% dynamic, okay? Because we need to know about the component that we're creating ahead of time. This means that we need to import this code into this file. That means that this code will be added to our bundle. So what do we do about that? We're creating dynamic components, or plugin components, you can call them, or lazy loaded components. So they are unknown in compile time, and they're lazy loaded. How do we do that? Well, oops. There are different ways to load them. In this case, I'm using Webpack and the Angular's methods that we have in our application in our code already. Angular gives us a loader, an ng module factory loader, which actually comes, well, it is used also in the router. We'll see that. So you need to either use the router, then it will provide it, or you can provide it by yourself. And then you just load a string. And a string, it doesn't need to be known, like the file itself doesn't need to be known in your development time or in build time, because it's just a string. And you can load this, the string from the server, for example, if you have several different components, modules that you want to load. This string is for the module, because we can't just load a component dynamically. We need to load, not dynamically, but lazily. We can lazy load an Angular module. So we're loading the module. We're creating it from its factory. And then we can create the component that we have inside. Okay, so this is the way that you will provide the ng module factory loader. This is the way that it is done in the router using System.js, actually. And if you want to build parts of your code, some Angular modules, lazily, with the Angular CLI, with the Webpack, then you need to add these modules to Angular JSON over there in lazy modules. Okay, but still we have a bit of a problem because we resolve the component and we still know the component there. So what can we do about that? We can use the providers. This is the lazy loaded modules. So we can add the providers there, and we'll ask for the provider. We need to know the provider name, the string, but that's it. We don't need the code. Okay? So this is one way to do that, or if you want to be more safe with the types, then you can actually create a whole interface and injection token, and then you can just provide this token. And this token will be known in our application and also in the ng module that you're loading. And now you can just get the widgets token that we have, that we've resolved with the injector, and get its value from this module. Okay? And we just get the component from over there. And now it's perfectly lazily loaded. So what do you think? Have we succeeded in our mission to make lazy loaded plug-in dynamic components? Yeah. All right. Great. I think we achieved this. OK, so a few things that you need to consider. You can load modules in several different ways, and one way that you can do this today is also with ES modules, dynamically loading them. But you should check whether you're using Webpack, which will use it, do something else with that. So maybe you should choose a different build system to do this, maybe System.js. You can bundle a different project as a library without having the whole application that it needs. Just put in the Angular JSON of it, vendor chunk true instead of false. You'll find it there. And then it will not bootstrap the application and everything. The next step that we're going to have that will be safer to use dynamic components, to use others' components, is with web components. So you should check out how you're going to do that if you want to allow, for example, components written in different frameworks or even in different versions of Angular. Okay, because components written in version 6 will not be loaded as you expect in version 7 if they're used dynamically. And of course, in Ivy, we're looking forward for more improvements in this area of dynamically loading everything. So these are the resources that I've mentioned. And also, another thing that I know that I'm already taking a few extra minutes of your time, but another great thing that I want to show you is the demo by Manfred Steyer, who has actually different types of components. A regular one, let's a lazy loaded one, and an external component that is built as a web component. So please check out his code. And that's it. I hope you're going to use now dynamic components a lot in your applications and see how they improve your performance and your code quality. I'll be now in the Q&A session. You can ask me questions there. And I hope you enjoyed the talk. And if you want to help out or ask anything, then you can also reach out to me in these channels and help us with NG Girls. So thank you very much.
Thanks very much. Actually, I think you're in the office hours next, so that's where to catch up with Shimona if you've got any questions for her. We're taking a couple of minutes break now. Join us back here for Sunny, or opposite in track 1 for Olivier. Thank you. Hi, welcome back. So up next, we have Sunny, who's the founder of Hybrid, a London startup that uses Ionic. Sunny also co-manages the Ionic UK community. He's here today to talk about coding across web, mobile, and desktop using the same code base. Let's hear it for Sunny.
Okay, 30 minutes. Hello, everybody. How we doing? Good, good, good. All right, all right, all right. Okay, thank you very much for the intro. So, today we're going to talk about crossing across platforms. What does that mean? Some people are just like, okay, what does that actually mean? So hopefully in the next 30 minutes, I showcase exactly what I mean by crossing across platforms. Before I begin, I'll tell you a little bit more about myself. Thank you to Wasim for this great stuff. So I'm Sunny, I'm the founder of Hybrid. Not as fancy as it sounds, actually. It's kind of just me working there, so don't, it's not too much. I'm also a Google developer expert, which means I'm one of the cool kids that Google decides to give some free tickets. I don't know how I got in, but shh, don't tell them. So I'm a huge fan of the Avatar movie. Has anyone not seen that movie? Anyone? So everyone has seen the movie. Good, good, good. You see? That's good. All right. You can find me online, Sunny Yusuf everywhere. Really, really easy. It's the same username everywhere, like pretty much sunnyyusuf.com and all of that. I always say if you can find anybody that looks this ugly using that username and it's not me, then let me know. Good. Okay. So let's begin. It's been a great year. 2018 has been a great year. One or two not so great things, but generally it's been a great year. So, this is you. You have a great job in 2018. Really, really awesome job. You're working for Amazon for like $2 an hour or something like that. No pee breaks, You have well-tested code as well, How many people actually test their code? No, not like half test. They actually test the code. Good. Okay, good amount of numbers. So you have well-tested code. You're doing your little TDD. You have unit tests running. You have CI, CD, all of that. All the continuous things working. And your football team is finally winning again. That's the most important part. Exactly. After 21 years of agony, they're finally winning again. If you know, you know. And summer in England is absolutely awesome. It's still summer. We're going to have one hell of a winter, I believe. It doesn't come for free. What could possibly go wrong in your life? What could go wrong? Can anybody think of anything that could go wrong? Don't be bad. Okay. Along comes this guy. You know this guy? I call him the client. This is the guy, the client. This guy is the biggest. Okay. It's really nice. He's got a lot of money. This is the one guy that can fire everybody in your company, including your boss. Do you know how? By not giving you his money. That's the one way he can fire everybody, even the CEO. The guy comes, and clients love to, I don't know what goes on in their head. They sleep and they wake up and they come up with the most interesting requirements. I want a spaceship. I want this. I want a submarine. I want to use a submarine to go to space. It's crazy. Exactly. So what does the client want? This is what the client wants. He says, I want a mobile app, and I want a desktop application. And this is assuming you already have a web application for him, right? He says, I want these two. Everyone has an iPhone now. Everyone has an Android phone. Some people still use BlackBerry mobile phones. Some people still have Windows phones, So I want one of those. And you can't really say no. Just like Bruce Lee, you can't really just say no. Eventually you give in. You get knocked out. That's a given. So your manager, the one guy you think is going to stick up for you, nope. Your manager just says, you got to do what the client wants. He says, you have till the end of the month. Why is it that every single manager, no matter what country, no matter what language, no matter what continent they're from, they always use this one line? You have till the end of the month. I don't understand, And there's always never budget. There is never, ever budget. If your manager has budget for you, marry that manager. That's a great manager. There's never budget, no? And if you're lucky, your manager might tell you, good luck, you know? Exactly. Now, this is you, you know? Because you call the wife, it's gonna be a late one today, you know? Nothing seems to be working, you know, because you're trying to fix this problem, right? Okay, and it's not easy. So let's talk about what you already have. You know, client has given you a new requirement. Let's see what you already have. So you have a web app built with probably a server technology, most likely. How do I know? Most likely you have some .NET type of, you know, existing website, robust, well-tested, you know. I'm pretty sure there's a lot of Microsoft people in the room. I know Microsoft people because I can see them, you know. Exactly, yeah. Microsoft people. Or maybe Java. I also know Java people because I used to be one of them. And PHP people, I know them because they age the quickest. Exactly, I know that, exactly. So maybe you have one of these server-side, you know, web applications that works really, really well. You spent millions of dollars, years and everything, building this great thing. But now, you need to build a mobile app, you need to build a web app, and you've spent millions of dollars in this infrastructure, right? So this will be the rookie, I say, very ignorant first attempt. All right, we need a mobile app. Okay, we're just going to go and create a team, a mobile team. Remember, there's no budget. So you're going to go learn Android and iOS and all of that, right? You go learn that. That will be your first attempt. You know, educated attempt. You'd go through that. All right. And you create a separate repo for the desktop application, right? And by the way, if you hear me say desktop, that's just how I say desktop. It's kind of like a Nigerian thing, so sorry. Exactly. So life is good. You fixed the problem, right? No. This is what you didn't consider, no one told you. You know, code sharing across platforms. How are you going to code share across platforms? You're going to support Android, iOS, you know. So if you already have like a .NET application, how the hell are you going to reuse that? You know, because Android is what? Kotlin or Java or C++ if you're like really, really mean. For iOS, you have the most beautiful language, Objective-C, you know, or Swift if you're sane. And yeah, so you have that. And they all have different set of tools, and you probably need more hands. The only way you can stay sane and get a working application that is, you need more people. But remember what the manager said, no budget. You have to do it. Okay, so what do we do? All right, this is you again. This time you've completely given up. You know, you want to leave your job, but you know, you need the money, the mortgage, the kids, you know, exactly. We know the story. So let's solve your problem. Let's solve your problem. So this is what you want in theory. In theory, what do you want? You want the ability to use the same technology across all platforms, right? You want to make sure if I have a web app written in a specific technology, I can take that technology and create the mobile app, and I can use the same technology for the desktop application. That's fair, right? That's theory. You know, we want to be able to write these applications in pretty much the same programming language. It would be pretty cool. I wouldn't want to like be writing Java one day, the next day I'm writing, you know, COBOL, and the next day I'm writing Fortran. It's not really nice, you know. But this is one of the most important parts. You really want to share the code. You want to be able to share the code base. If I write a component for my web application, it would be really, really cool if I can use that same component in my mobile application, or at least to some degree. That would make sense. I need to be efficient, right? And you also want to be able to use similar sort of like processes and build tools. That also really, really helps you. Because one of the things we developers like to do is, especially the Java people, the app is building, you know, just stay, and for the next 2 hours the app builds, and it's always going to fail, but that's okay. So let's make a case for Angular. I'm going to tell you why Angular can actually help you with this particular problem, right? So why Angular, first of all? What is Angular? Some people call it a framework. Some people call it a library. Depending on who you ask, and how React they are. They might have favorable things to say, some might not, and depending if they've done AngularJS or not, so depends. But generally, Angular is, if we use the word the framework, it's a framework that allows you to go across platforms. If you look at the actual Angular web page, they use the word platform a lot because it can run on both browser environments and non-browser environments. And one of the reasons why I think Angular is a great case for a scenario like this is, first of all, rich API. Angular has really, really robust API, and that's why it's very popular across enterprise. You have things like reactive forms, right? Which probably is my favorite feature of Angular. HTTP client, you can really do a lot of things with the HTTP client and the client module. You can, do interceptors, you can play around with service workers and all of that. And the router is very, very, very robust as well. It took a while to create it. I mean, it's such a great router. The guy that wrote it left the team and started a new company. Became really successful too. So that's how good a router it is. Localization and internationalization. I believe right now, Olivier Ocombe is actually giving a talk, and he is like the king of localization. So if you support multiple languages and things like that, because we kind of forget that the whole world doesn't really speak English. Because it's, as English speakers, if somebody doesn't speak English, it's almost like they're doing us a disservice. Like, why don't you speak English? We forget, And also the component structure and the component library. That really, really, really makes Angular a great framework. And other features, enterprise friendly. I'm missing an S there. You can do server-side rendering, right? If you SEO is critical to you. You're working for a magazine or something like that, where SEO is like a make or break thing. Server-side rendering, and that's where Angular Universal comes in. Still using the same set of tools, but you can render on the server side. The CLI is great. You can do all of that, because I always say with tooling, I don't like tooling. Hands up if you actually like messing around with tooling, like Webpack and all of that. Does anybody actually like that? Now we know where the serial killers in the room are. Yeah, exactly. Be careful with Webpack and all those things. I always say, if you venture into the tooling layer, only few people make it back out. Very few. Very few. Exactly. I've seen people give up their careers after just one day of Webpack, like, nope, this is not for me. I'm just going to go do music. Exactly. And the greatest part of Angular is the super community, right? The community is the greatest part. That's why we're all here. I've been to 5 continents in the world talking about Angular, and that's because everywhere you go, there is a robust community of people that are solving the same problems. And there's a very non-toxic community as well, which is great. Linux, PHP, take note. Exactly. So let's create a hypothetical use case, right? This is what we want. Very similar thing like this, what we want an iOS, Android, Windows mobile sometimes, because enterprise people, desktop web app, things like that, and we want a desktop application as well, right? Pretty fair? Right? Okay. So let's try to see what the web solution would look like, right? Okay. So this is what your typical web solution would look like. You would have your application, then you would pick some sort of UI library, or if you're like me and you're lazy, you'd go to Theme Forest and buy a very nice theme. Pretty good, $50, does the job. Client does not have to know. Exactly. It's true. If they don't know, it wouldn't hurt them. So you take your app, you build that on top of some framework, UI framework, Bootstrap, material design, you slap Angular on top of that. Of course, you should be using TypeScript. If you're really not using TypeScript, I don't trust you. Yeah, exactly. And then, of course, JavaScript sits on top of that, or ES, whatever version, because now if you say ES6, you can offend somebody. So ES Next, or ESX, as they say. Exactly. And of course, you can still decide for your application to go either the SPA route or the Angular Universal route. Doesn't really matter. You still be able to use the same tools to achieve this web solution, right? So for the mobile solution, pretty much the same. I want to be able to write my mobile app, choose some sort of framework. And for that framework, I would use probably something like Ionic or NativeScript. Why? Because they both have solid integrations with Angular. So I still haven't, like, I've separated what I'm doing and what I'm delivering from the core. And that's the great part. Those of you who know me know which one I'm a fan of, but that's a story for another day. So let's go to the desktop solution. Pretty much the same thing, but there's this little difference there. And you use something called Electron, which is something that will sit on top of your application, and that you can support Mac, Windows, or Linux. All three of them, you can support that. But the great thing is you're using one code base. And the greatest part of desktop is the difference between the web and desktop is very little. A desktop application and a web application are targeted to really people that sit on a desk, or on a laptop and use, like, take advantage of the full screen, which is not too different to a web application. So if you already have an existing web application built with Angular, porting that to the desktop becomes really easy with Electron, because nothing really needs to change. Electron will just give you the integration to, like, the APIs that the computer gives you and the shell. But that's it. The look and feel can stay the same. If it's responsive, it's great. All right. So now, the first question, or the first thing that would come to your mind is, how do you share code with all these, things that are, these ideas? Because right now, you still haven't solved anything, right? Ionic CLI to the rescue. And you can actually, since CLI version 6, I think, you can actually do something called ng-generate application, which means you can actually add a sub-application within your main application. So not only normally when you do ng-generate with an application, you create a new Angular application, but now you can actually have, like, mini apps that all are built within the same configuration. So basically, it favors that monorepo type of strategy, right? And there's also another one, which is ng-generate library. You can basically add a library, a shared library. So if you can add applications and libraries, a good part of your problem is actually been solved. And I would explain why in the next few slides. So first of all, how does it all fit together? So you have your web application. You do your ng-generate. Your web application would most likely be the main app that you do your ng-new with, that you'd start off with. Then the mobile would be like a sub-application. The desktop app would be like a sub-application in the same monorepo. Then what you do is you create a shared library. And you take that shared library, then you share all the code inside the desktop and the mobile and the web. So if you have, like, for example, an authentication module or something like that, right? You can just create that in your shared library, and all of them will use the very same authentication module. To some degree, you can share routing depending, but really now you have a safe space where all the common things can live there, and you can just pick and choose them, right? So basically, this is where monorepo approach really, really shines, because you can reach out at any point in time. And it's so much more easy for your build tools, continuous integration, continuous deployment to really work, because everything is in kind of one place. The bad part is if you're starting a brand new job, you spend 1 hour downloading a maybe 2 GB repo, but you only need to do that once. That's a fair trade-off. Like I said, that shared code will be imported as an ng module. Pretty similar to how you use something like material design. You just import a bunch of ng modules, whatever you need, right? So then, Mr. Client comes again, and he has a weird scenario. What is the scenario? So you have 3 apps, mobile, web, and desktop, right? You have components and modules inside that shared module. Everybody understand that so far, correct? OK. But the components have some shared logic, which is expected. That's why we have a shared library. But the most important thing is now they have some platform-specific logic. So there's something, this component needs to behave like this on the web, but only on the web. This component needs to behave like this on mobile, but only on mobile. This component needs to behave like this on desktop, but only on desktop. Now, you might be tempted to say, oh, I'm just going to create 3 components. then think about when you have a library of 500 components. Are you going to create 3 flavors of 500 components? That's around 1,500 components. Nobody wants to get paid to maintain that. Trust me. Creating components is easy. Maintaining them, that's the hard part. So what do you do? So this is the scenario here visualized. We are all guilty of this, aren't we? We are all guilty. It's okay. I would not, your secrets are safe with me. We're all guilty of this. You know, we have some ngIf in the template. We use the smart component pattern. Oh, if it's desktop, show this. If it's mobile, show this. If it's web, show this. Pretty good. It's easy to get away with, right? We all do this. I have code bases that are still writing this. The problem is, you know, we can end up what I call a God component. The component that wants to do everything. And there's actually a code smell for this. The code smell, I kid you not, is called inappropriate intimacy. That's a legit code smell. It's a legit thing. I did not make this up. You can Google it. It's called inappropriate intimacy. When things that are not supposed to be, you know, having access to each other are just there. Because what happens now is, in your application for mobile, you're using the behavior specific to mobile, but there's still code that's just lying there, dead code. And guess what? Most likely, even tree shaking might not even remove that, because it doesn't really know, is this going to be used or not? So things like that. You have that particular mobile component flavor, but you have the web code inside there. So how do you actually solve this problem? Okay, let's see how we solve this. The first way is we can use component inheritance. And I actually like this method, and it's easily the most underused method in Angular. For some reason, we as Angular developers, we seem to forget that component inheritance is a thing. And I think maybe it's a case because a lot of people that write in Angular have come from like traditional JavaScript background, where we're used to prototypical inheritance. So now object-oriented inheritance is like, we don't want to do that. I don't know why, because I like object-oriented inheritance. So you'd have something like this, you know? You'd have, let's say, in that your shared library, you'd have some component, right? You create that component. But for that component, you'd absolutely give no implementation to your template. 0 implementation. This component, I call it an abstract component. Think of it as the same way you think about an abstract class. What is an abstract class? It's a class that cannot have any implementation, but can only be inherited, right? It exists just to give implementations. And that's what you would do with this. So you put your shared function, where what mobile, web, and desktop want inside of there. But then, when you go, for example, to your mobile code, you'd create another component that basically just shadows that. I call them shadow components. All it does, it inherits from that component in your shared library. That's all it does. So now, if you want a mobile-specific things, or your client comes and says, I want to be able to do this, you don't need to go to that shared component and break everything. You just go into this component that extends, and you put all your implementations there. And that allows you not to really break stuff. Okay? So, problem solved, right? Not really. What about white labeling? What happens when you want to white label? Does anybody work in a company that does white labeling here? Your thoughts and prayers are with me. Don't worry, my brothers. We shall prevail. So what exactly is white labeling? This is the scenario of white labeling. Basically, you would have like an app skeleton, right? Sort of like a shell that you build. And when you build that shell, the app itself, the skeleton itself, is also an abstract. It's not an app that you sell. But when the client comes and says, I want to buy from you, you then, sort of like create an app based on that shell. It's basically, I always say, white labeling is not too different to politicians. Like, on the outside, they look all different, but internally, if you really dig deep in, they're all the same. So very similar. And some customers can really want specific things. There's that customer that wants that one thing. And for example, how many people know that for a Boolean state in a checkbox, apparently there's actually 3 states, not 2. There's check, unchecked, and there's also the interdeterminate state. Because there was one guy in the world that had a company that needed that requirement. There was one guy. And they're like, oh, we might as well make that for him. So it's things like that. So this is what a white labeling application would look like. You have client A, client B, and client C, all using and sharing, right? And so what's the solution for this type of scenario? The first thing is you create configurable modules. Very, very, very important that you create configurable modules, because that's how we use like Firebase and all these types of things. It basically allows you to create a module that can be configured. Please, oh please, use injection tokens. They're not pretty, but please use them. This ensures that now, when you take that shared module into a white label application, the application you create, the white labeled application, can police its own implementation. You know, think about that. If Firebase, like when you use Firebase, you provide the API key and all of that, and that's how it knows, okay, this is you. Because if you're creating a white label application, this particular client would have a different database, would have a different authentication flow, and that kind of thing. So you can sort of create an injection token that will allow you to do that. And I actually have something that looks like. So this is what your implementation would look like. You'd have a module. I have a module here called configurable module. You would provide some sort of like configuration, and you create an injection token, and you always, please, in the providers, it's very good that you use the use value so that to avoid conflicts. So you'd provide the token, and you'd like use the injection token method. And then you can, in all the services or where that particular components where you need to use that injection token, you can just use dependency injection to resolve it. This is what that module would look like now when you want to use it in an application. You just go and provide your configuration, all the API keys and everything. That means now you have this linear way of maintaining your modules on the long run. And that's very important because maintenance is where we really, really want to focus on. But you know what? I can sit here and tell you about, you know, how you should share code and structure your architecture. But in the end, your requirements should be the one that speak the loudest. Let your requirements speak. You know, don't go back to your workplace and say, I heard Sunny talk about this, and that's what we have to do. Nope. When you're looking for a job, I'm not going to be there. Exactly. Look at your requirements. Okay, what are we trying to solve? What are we, you know, trying to do? And then come up with scenarios. I'll give you a scenario, for example, that I recently had to, which is a very non-orthodox scenario, where we have a white-labeled solution, a healthcare application, and we have different types of people that want to use the same content in our healthcare application. And what did we do? We actually ended up creating, for each content that we have, we created a lazily loaded module for that content. Now, it seems like coupling, but we like to call it cohesion just to get away with it. But it's what works for our own specific use case. There is no right or wrong. Now, some of the things I've shown here today would cover a lot of your use cases. But in the end, always make your requirements speak first. That's very, very important, right? So that has been everything that I would want to show you for my presentation. And if you have any specific requirement, if you have any questions, you can catch me on the break. I can go into requirements. And we have like 1 minute, so we can actually take questions. But yeah, we have time for questions? I have a minute now. OK, all right. So I've been told we don't have time for questions. So thank you very much for having me.
Thank you. Thank you very much, Sunny. I'm sure you can catch Sunny around over the next few minutes. We're now closing this track, and everyone's heading over to track 1 for the last thing of the day, which is the Angular team panel. If you haven't submitted your questions yet, you can still on Slido using the event code Angular Connect. Thanks very much.